Welcome, everybody. Our group is excited to share with you our presentation regarding the occupational hazards associated with the solar industry. The expansion of this industry has brought forth 2 points of discussion, one related to the environment and the other related to worker safety. As you are all aware, CO2 emissions are a large contributor to global warming, with different energy sources producing a different amount of CO2. This figure on the right shows the global warming potential for different energy sources. You can see that coal, oil, and natural gas have the highest global warming potential. Nuclear energy has a much lower global warming potential. And then solar energy, which would be contained in this other renewable section, has an even lower global warming potential. Given these relationships, hopefully solar energy will mitigate the negative effects associated with gas, oil, and coal on our biosphere. The solar industry has been expanding. This figure shows that solar panel installations have increased from 2012 to 2017. This has occurred across all three sectors reported in this figure: residential, non-residential, and utility. You may notice there is a decrease from 2016 to 2017. This may largely be due to landscape constraints, market profitability, customer acquisition challenges, and the availability of panel installation companies. However, despite these constraints, the solar industry is projected to continue to grow. When compared to other occupations, the solar industry has been projected to be the #1 fastest growing occupation from 2016 to 2026, estimated to increase by 105.3%. Specifically, this means by 2026, we should see over 23,000 jobs in this rapidly growing industry. The growth of the solar industry has created a number of new jobs. Additionally, the Solar Energy Industries Association has a set of guidelines to protect workers that is based on potential exposure, such as fall or electrocution. Despite these guidelines, we still have a poor understanding of the actual quantity of injuries from panel installation. We also don't know a lot about long-term injuries, such as prolonged ultraviolet exposure or repeated heavy lifting. So despite these initial guidelines, it's important to reevaluate them as we gain more data as this industry continues to expand.
With regard to photovoltaic occupational safety, there are differing exposures depending on the stage of involvement in solar energy production. These can be broken down into 4 stages, including 1. Raw material mining and processing, 2. Construction and assembling, 3. Installation operation, and 4. End-of-life cycle and recycling. The potential hazards are well documented for the first stage, solar cell production, and these are mainly chemical in nature. Although not exhaustive, a few of the hazardous materials of notable concern are listed here. The primary routes for occupational exposure include chemical burns, explosions, and inhalation of fumes, as a great deal of the materials used in manufacturing are highly toxic and flammable, such as silane, a byproduct of crystalline silicon solar cell development. Workers may be exposed to hydrofluoric acid or other acids and alkalis used for cleaning purposes, as well as dopant gases and vapors due to improper ventilation. Further, exposure to cadmium compounds can be carcinogenic, as cadmium is considered a lung carcinogen and is regulated by OSHA. Other routes can include hand-to-mouth contact or accidental ingestion. Installation and operation presents a less studied risk for occupational workers in the PV industry. Due to the nature of installing solar technology, falls from heights are a significant risk. Health effects associated with falls from roofs can include, but are not limited to, skeletal muscular injuries, brain or spine injuries, concussions, lacerations, bruising, swelling, long-term disability, and/or mortality. This risk can be worsened when roofing is old or damaged, or when panels are located close to edges, skylights, and vegetation. Lack of fall protection, proximity to overhead power lines, and unguarded skylights can also be contributing factors. One suggestion to prevent falls includes locating panels on the ground whenever possible or incorporating the technology into roof membranes, shingles, wall panels, or windows. Aside from falls, there is a risk for electrocution from solar panel installation or nearby power lines, as well as ergonomic risks from heavy loads or a lack of lifting equipment such as ladder hoists, swing hoists, or truck mounted cranes. Cold or heat stress and exposure to UV radiation from sunlight can also occur. Installation ultimately combines the exposures of three separate industries into one, including roofing, carpentry, and electrical work, all of which carry high occupational risk. There may also be a risk for infectious disease spread amongst PV employees. Solar farm or large-scale solar power facility construction requires soil disruptive work, which can precipitate exposure to soil-dwelling organisms. Such cases have been documented in San Luis Obispo County, California, where 44 workers came down with coccidioidomycosis while constructing two solar generating facilities. This infection, also known as valley fever, is caused by fungus spores and causes flu-like symptoms. However, complications can result, including meningitis, osteomyelitis, or cutaneous lesions. These can lead to fatality if not treated. Thus, improved worksite dust control measures are advised. Lastly, end-of-life recycling is also a large source of hazardous chemical exposures for workers. Green recycling requires increased material handling and manual separation, which can demand 2 to 3 times more individual handling of materials. This can present a risk for strains, sprains, and punctures. End-of-life materials can include lead from electronic circuits, as well as brominated flame retardants, polybrominated biphenyls, and polybrominated diphenyl ethers used in circuit boards and solar panel inverters. These are considered toxic and potential estrogen disruptors as these bioaccumulate in fatty tissues. As this list is not exhaustive, for a full potential chemical and hazardous material exposures during production or recycling, please reference the Silicon Valley Toxics Coalition.
As discussed earlier, solar panels provide us with the abundant, clean energy needed to supply electricity. However, we still face scientific limitations that prevent us from capturing the vast energy produced by nature. The first, most obvious scientific setback comes from the unpredictability of when solar energy can be available. For instance, during nighttime and cloudy days, solar panels do not absorb any energy. This is demonstrated by this picture. Also, solar radiation has a very broad spectrum, which ranges from infrared to ultraviolet, and it's very challenging to design a device capable of utilizing all solar energy. While the cost of maintenance and operating are relatively low, solar panels are fragile and easily damaged. For example, damages can come from hailstorms or natural disasters. Most importantly, in comparison to other renewable energies, solar panels' efficiency levels are relatively low. Those levels are around 14% to 25%. The UN Intergovernmental Panel on Climate Change estimates that the world will need the equivalent of 32,000 terawatt hours of electrical energy by 2030. Solar panels alone would only produce about 150 to 300 terawatts, which is only about 1 to 2% of that demand. Although there are some scientific limitations to solar panels, we can continue to use them in tandem with other forms of renewable energy, such as wind, to increase effectiveness.
Exposure to toxic chemicals and other occupational hazards have presented many challenges with the installation of solar panels. There is no doubt that the use of solar energy has numerous benefits, including using sustainable energy and reducing greenhouse gases. However, due to the rapid growth of the photovoltaic industry, occupational hazards have increased for workers in the manufacturing, installation, and maintenance of solar energy. The occupational and health aspects of the PV industry have not been thoroughly examined. A few other challenges facing workers are exposure to toxic chemicals, electrical shock, and risk of falling from dangerous heights. During the manufacturing process, workers are exposed to a variety of toxic chemicals. Some of these chemicals, such as telluride, cadmium telluride, gallium, and germanium, are still under study. Other chemicals like chlorosilanes and hydrogen chloride are not only toxic but highly volatile and explosive when mixed with water. Many solar PV technologies use extremely toxic material that have unknown health and environmental consequences, including new nanomaterials and processes. There is limited data on specific air emissions and liquid or solid effluents from PV cells and processing. This is not only problematic for occupational health, but also for environmental health. A risk assessment for these chemicals addresses hazard identification, risk of exposure, and an emphasis on dose-response relationships. The use of personal protective equipment is another resource that is used to reduce exposures of hazardous chemicals. The installation phase can also prove to be problematic and pose a serious risk for PV workers. According to the photovoltaic industry on the path to a sustainable future, the occupational injuries of PV workers have also been the subject of very few publications, although the safety aspects of solar panel installation has been highlighted. Fatal falls from the installation phase have been reported from California and in France. Enforcement of standards, workforce education, and regulations are some ways to prevent falls during the installation of PV panels. The United States Department of Labor's website lists different resources for preventing and controlling hazards. They promote safe work practices and provide workplace training requirements.
Clearly, there are a number of concerns for workers in the solar panel industry, and unfortunately, current policy is lacking to protect workers from occupational hazards. OSHA currently requires employers to implement and provide safety training for workers, and employers are also required to provide safety equipment. Examples of both are listed here. While companies are required to provide safety training and equipment, it is ultimately the responsibility of the worker to carry out measures to protect themselves from injury. These measures are only effective if every worker follows safety protocol at all times. The majority of these measures fall under the category of personal protective equipment and a few under administrative controls. As you can see, these are the least effective methods to ensure safety. As mentioned, solar panel installation is a quickly growing field. As the number of workers in this field grows, the number of work-related deaths and injuries is likely to grow as well. Safety measures need to take place on a larger level. In recent years, the National Institute for Occupational Safety and Health launched the Prevention Through Design initiative. This initiative strives to improve the health and safety of workers by taking a comprehensive approach to eliminate hazards and control risks earlier in the process. Electrical work and construction are already being researched through this initiative. By using this information and recognizing the unique nature of this occupation, solar panel installation safety can be greatly improved. Policies addressing the hazards associated with solar panel manufacturing have the potential to create substantial improvement in worker safety as well. Research is currently underway exploring the possibility of replacing some of the more hazardous chemicals with chemicals that have fewer risks to the exposed workers. Once research is complete, enacting a policy that requires companies to make this change would make great strides at decreasing the health risks associated with PV manufacturing. Finally, I just want to mention that in 2013, SEIA introduced the Solar Industry Environmental and Social Responsibility Commitment, a voluntary set of guidelines for companies in the solar industry to follow. Companies can choose to sign and agree to adhere to recognized best practices, including those for worker safety. Although it's not an official policy, it is a step in the right direction to ensure the health and safety of workers in the solar industry. Thank you for listening, and we hope you learned a little something about the solar industry and its associated occupational hazards.